Right now, most autonomous AI systems operate on fragile guardrails. We hand agents access to live terminals and simply hope the text in their system prompts is enough to keep them from breaking things. Kirk LaSalle designed PRISM to replace this fragility with a structural solution. The objective is to move the industry from a culture of trust me to a cryptographic standard of verify me. PRISM is an agents-as-a-service platform. It bridges complex machine operations directly with human calendar and project management workflows. In this system, governance is the load-bearing foundation of the entire runtime. Governance is the architecture. To see how this functions in practice, we are going to examine the platform from its cryptographic bedrock all the way up to the human interface. The design proves that verifiable safety and advanced AI capability are complementary forces. True AI autonomy is impossible without structural safety. Without these constraints, autonomous agents remain a liability. With them, they become reliable tools for human growth. At the absolute bottom of the PRISM stack are the permanent active directives. These rules build on Isaac Asimov's 3 laws of robotics, expanding into 10 distinct laws covering modern requirements like data privacy, equity, and operational boundaries. They mandate human preservation above all else and explicitly prohibit the AI from self-replicating or attempting to rewrite its core directives. These laws function as constitutional code, enforced through a cryptographic SHA-256 integrity hash. The platform verifies this exact hash at boot and then continually re-verifies it every 600 seconds during runtime. If a single character of the directives is altered, the hash breaks. The system detects the mismatch and instantly triggers a total architectural lockdown. Ethical guidelines are ineffective when they can be bypassed. Cryptographic enforcement turns safety into a physical law of the runtime environment. With the foundation secure, the next problem to solve is ghost actions, tasks executing autonomously in a network with no traceable human owner. PRISM eliminates this ambiguity through character accountability control. Every single operation is wrapped in a mandatory identity chain. This chain records 4 specific links: the assigned character ID, the PRISM user's email, the human operator's email, and the precise session ID. If an action packet attempts to execute without this human lineage, the platform rejects it at the gate. Autonomy scales safely only when every machine decision maps directly back to a responsible human operator. Once an identity is verified, the system has to ensure the requested action is actually safe to perform. This evaluation happens inside the constitutional causal compiler. Before a tool is ever invoked, this compiler intercepts the agent's raw intent. It cross-references that intent with system policy and memory, outputting a constrained, executable plan graph. If the compiler detects a high-risk branch in that plan, like a destructive terminal command, it intercepts the path and routes it to a strict policy gate. Evaluating the causal impact of an action before it executes prevents catastrophic runtime surprises. Most open-source agent frameworks rely on sequential toolchains. One model thinks, acts, and passes the result down the line. PRISM scales intelligence differently, using an architecture called spectrum refraction. A single user prompt is split and sent in parallel to 2 distinct cognitive hemispheres. The left model handles analytical reasoning. The right model focuses on creative synthesis. To prevent homogenized output, the platform enforces strict instance isolation. The left and right hemispheres must be cryptographically guaranteed to be independent models. Both of these parallel outputs are then routed to a third coordination model. This coordination layer uses structured XML tags to organize the analytical data and the creative concepts. The coordination model performs a deliberate synthesis, fusing the analytical data and creative concepts into a single compound output. Forcing independent, isolated models to synthesize their findings yields a level of cognitive rigor that single models cannot achieve. All of these underlying layers surface at the human interaction point. The operator dashboard bridges the standard chat interface with deep network and tool controls, providing complete visibility over the agent swarm. From here, the system enforces a strict 3-tier policy over all computer use operations. Tier 1 commands run autonomously. Tier 2 operations are conditional, executing only if an automated rollback plan is verified. If an agent attempts a Tier 3 high-risk action, like modifying a system directory, the workflow halts. It will not proceed with explicit human approval. Operators monitor these actions through live observability tools, tracking immutable activity logs and real-time efficiency metrics like the token efficacy quotient. The dashboard ensures the human operator always maintains final authority over the machine. When you look at the complete architecture, you see a closed loop of accountability. A single intent is filtered by cryptographic law, compiled safely, attributed to a human, reasoned deeply, and executed under strict oversight. This establishes PRISM as a foundational infrastructure for verifiable, transparent AI. It provides the infrastructure needed for accountable AI autonomy, a system where advanced machine capability and human oversight work as complementary forces. PRISM proves that safety, transparency, and advanced capability can only thrive together when governance is the load-bearing foundation of the machine.